So hey everyone, welcome back to another video on the channel. In this video, we are going to solve another problem in our DSA series in which we are dealing with conversions of different number systems into another number system. In this video, we will deal with how to convert octal number into a given equivalent decimal number. For a given octal number, we have to return its equivalent decimal number. So what should be our logic? So it is going to be exactly same as our binary to decimal video. If you have not watched that already, I recommend you to watch that so that you can understand this video better. So in binary to decimal, we were dividing the binary number by 10. Why 10? Because the decimal number, the number system in which we want our result is base 10 number system. So that's why we were dividing the binary number repeatedly by 10, extracting the remainder, then multiplying the remainder or the modulo of each division operation at every iteration with power of 2, with increasing power of 2. As you can see, in every iteration, the power of 2 gets incremented because we are multiplying the place value of the number. Why we are multiplying with 2 over here? Because our given or the original number system is binary. So to convert it into decimal number system, first we need to extract the value of this particular number. And we can get the value by multiplying the face value with the place value. And as we know, in binary number system, the place value of every integer or every number from right to left gets incremented by power of 2. So in octal number system, we will do the same thing, but we will multiply over here by 8 because in octal number system, the place value of every digit starting from right to left gets incremented by power of 8. Why? Because octal is a base 8 number system. So that's why the place value gets incremented by power of 8. And and here we have to do the same division by 10 operation because we are converting it into decimal number. So that is a base 10 number system. So that's why we need to recursively divide it by 10. Extract the remainder, multiply it by the place value, and add it up to return our result. So now let's move into the code editor and code out the problem. So here the problem is octal to decimal conversion. Given a non-negative integer n that represents an octal base 8 number, return its decimal base 10 equivalent. Do not use any built-in methods like integer.parseInt, and here we have a number and we have to return the number with base 8. So we do not have to use this built-in method which is capable of returning the decimal equivalent of a given octal number system. So we have to write the logic by ourselves. So here we have given a value in long format because our input range is from 0 to 10 to the power 12. So that's why we have used a long result over here. So first thing, we have a result variable already given over here. And the second thing we need is a power variable because in every iteration, we are incrementing the power by power of 8. So at the starting, the power is 8 to the power 0, that is 1. So at every iteration, we will increment the this power variable by power of 8. How can we do that? We can do that by multiplying the power variable at end of every iteration with by multiplying it with a 8. So we increment it in every iteration by 8 to the power 1. So our power variable increases at every iteration with power of 8. And until how long we have to continue this while loop? Until number is not is equal to 0. So then we have to extract the remainder. Our remainder is given by n percentile 10 because we are dividing it by 10. And then we have to add this into our result by multiplying it with power. And then we have to divide the number by 10 so that we can get the reduced number in the next iteration. And then at last we have to multiply this power by 8 to the power 1 at the end of every iteration. So that pretty much sums up our problem. And let's run this and see what's the output. So it's running, and as you can see, all the test cases have been passed. So we can also add one more thing over here. We can add a check basically. If the number is zero, we can directly return zero without entering this loop. So because this loop will not be running when our number is equal to zero. So that's why we need to add this edge case over here so that our problem is done and dusted, covering all the edge cases. So as you can see, the test cases have been passed, and that's pretty much everything about this video. I hope you like this video. If you have any doubt regarding this video or any previous video, you can definitely reach me out in the comments. I will be happy to answer your doubts. So till then, keep learning. Thank you.